Hey guys, let's continue not our program of soil mechanics. Okay, so with this video, we will try to start a new chapter, chapter number 3, which is about weight volume relationship. This chapter is very important for student. I mean, if you are a student and you want to continue and become a geotechnical engineer, you need this chapter. You need to know everything about this chapter and understand everything about this chapter. There are a lot of formulas in this chapter, but you need to not remember everything, all of them, but you need to know how to establish the formula. Very important. Okay. So in this chapter, weight volume relationship, these are the points we will discuss from introduction to the last point. We have 8 points. Okay. So in this video, maybe we'll talk from the introduction, of course, until this point 6. And we will try to finish the chapter in the next video. Okay. Yeah. Okay, introduction. So in the chapter 2, we have discussed already about the formation of soil and the size distribution, particle size distribution of the soil by doing mechanical analysis. Okay, that was chapter 2. So if you didn't see the chapter 2 yet, I recommend you to go back and watch the video related to chapter 2 before continuing this. Okay, so we have finished with that part, and in this part, chapter 3, we will talk about three phases system in the soil, three-phase system in the soil, which are solid particle, void space, and the the void can be filled with air or water. Okay, so we will explain in detail soon enough everything about this. So if we take dry soil, which has no water, of course, dry soil, the void in the soil, because if you take soil, you will have some void inside, even though sometimes very small. Those void are very small. So when there is no water, those void are empty or filled of like air or gas, natural gas. But if the soil is saturated with water, so the void will be filled with water. But if you have a moist soil, it means the soil is partially contained. The void in the water are not filled. The void in the soil, sorry, are not filled of water. So in that case, we talk about moist water. Okay. So in geotechnical engineering, we have established relationship between the weight and volume of soil. If you take soil sample, there are a lot of relationship, and these relationships include void ratio, porosity, degree of saturation, moisture content, unit weight, that include dry unit weight, saturated unit weight, and moist unit weight. So in this chapter, we will talk how, mainly I will show you how to build the relationship. I'm not asking you to memorize all the relationship. Find the way to build the relationship by yourself. The most important thing is that. Okay. Okay, let's go for the part 2, which is the core of this chapter, this video. Weight volume relationship. Okay, if you take soil like this, just soil sample. In this soil, you have some grains, grain particle, means the soil particle itself, but you have also water, and you may have also some void within the soil sample, the soil mass. Okay, so the soil mass will have, of course, a weight. We'll call it total weight, and it will have a volume, a total volume. What we will do is we will take the soil sample, the soil mass, and we will separate the void, the air in the soil. We put up here. The water in the soil mass, we put here. And the soil particles themselves, we will put them here. And what we will do is, if we do that, we will get three phases, which is solid, solid phase, liquid, and gas, right? So if we get that, it means in soil, we might have these three phases in the soil, and each phase has mass and volume. Okay, if we take, for example, the solid phase of the soil mass, which is only soil particle, we will have Ws, means the weight of the solid phase, Vs, the volume of the solid, S is standing here as for solid. Okay, so Vs, the volume of the solid part. If you go to the liquid phase of the soil, our soil sample, the liquid phase also will have its own weight. We will call it WW. Okay, weight. This first W is for weight, and the second one is for water, because in our case, we will say water. The liquid phase of the soil is water. Okay, and VW, which is the volume of the water. And we will have here also for the air, VA, means volume of air. Okay, but for the air, we didn't put anything here for the weight. We will explain that very soon. So if we take the volume of air plus the volume of water plus the volume of solid, we will get the total volume of our soil sample, right? And if we consider that the void in the soil is the volume of water plus the volume of air. So, as we explained before, if the void are filled of water, then the soil is saturated. If the void are not filled with water, then maybe it can be like partially saturated or dry. If it is dry, it means no water at all. So in our case, it means this soil is partially saturated. So means the void are not completely filled of water. It's not 100% saturated. So remember only that for the volume of void, it is volume of water plus volume of air. So it means volume of void plus the volume of solid will make the total volume of the soil. So if you have understood this, then we can move next step. So as this figure said, I already explained about the volumes. I've already explained. So figure number 1A is the total, and we reorganize it to have the three phases: solid, liquid, and gas phase. So to understand this weight volume relationship, we need to separate. We needed to do these three phases, separate the soil sample in three phases, like solid, liquid, which is here water, and gas, air here. So the total volume is this. I have explained this already, right? So Vs plus V, which means volume of void. Vs, volume of the solid, plus volume of void. And if you go deeper, volume of void is just volume of water plus volume of air. That is here. So the total volume is volume of solid, volume of water, and volume of air. So by additioning the three phases, the volume of the three phases of this soil. Okay? Yeah, let's continue. Okay. Volume of solid, volume of void. And this one, W, volume of water, volume of air. Now, if we assume that the air is very light, it doesn't weigh that much, almost zero. So we can neglect the weight of the air. In that case, we can say that the total weight of our soil is just the weight of the solid part plus the weight of water. That's all. So here we don't need the gas phase of the soil sample for the weight. Okay, just these two are enough. We neglect that's why here there is nothing as mass or weight of the air. Yeah. So weight of solid, Ws, weight of water, Ww. These two are very important also, because when it comes to weight or mass, we will consider this. Okay, for volumes, we will consider this. So if you need to understand this, really. Three phases: solid, liquid, gas. The liquid is just water, the gas is air. For the volume, we addition the three phases, the volume of the three phases to get the total volume. For the mass, we just do volume of solid plus volume of water. We consider that is the total weight, total mass, if you wish. Because some people will work with mass, some people prefer to work with weight. So I hope you know the difference between mass and weight. Mass is just in kilogram, you know. Weight is like weight, how to explain in Newton or kilonewton. That's the difference. Okay, so I'll keep this figure here because we will use it from now on. And I need you to really understand what is following just right now, because all along this chapter and of course during this video, we will talk about this. Very important. Void ratio. The first relationship. What is void ratio? The void ratio is volume of void divided by the volume of the solid part. VV divided by Vs. This is void ratio. This will indicate you how porous your, how to say, the void, the ratio between void and the soil, how porous your soil, your ground is. Please remember this formula forever. From now on, you should remember this formula. You should never forget it. Volume of void divided by volume of solid. Okay, number 2, porosity. What is porosity? Porosity, volume of the void, and you divide by volume, the total volume. This is also kind of ratio to see in the total volume you have what is the amount, I mean the percentage of void in the total volume of soil. That is also important. So don't confuse these two. And it's very common to get these two, one from the other one, like this. So if you have the porosity, if you need porosity, you can obtain it from the void ratio by using this formula. And if you have the void ratio, you can obtain the porosity by using this formula. You can establish these two by yourself. It's not difficult. But you need to know the meaning of the void ratio and the meaning of porosity. You need to remember this formula. VV divided by VS, VV divided by VT. The thing is that all of them are starting by VV, volume of void. So remember that for E, the bottom one is VS. And for N, the bottom one is VT. If you can remember that, then it's easy. Next, the degree of saturation. Sometimes we need to know if all the void are filled of water, or the amount, like the percentage of filling. So for that, we divide the volume of water by the total volume of void. In that case, it will indicate you if all the void are filled of water or not, or if it is 100% filled of water or not. That's the meaning. So volume of void, you divide it by volume of volume of water divided by volume of void. And you sometimes we do this as percentage. You multiply by 100 to get it in percentage. And even here, sometimes porosity, some people estimate this as percentage. So by multiplying by 100. Degree of saturation. Next, and just before I continue, these three, 1, 2, 3, these three are using only volume relationship. Do you see? Everything here is about volume. V, 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 V. There is no way in these three you see a weight. Okay? So it's easy to remember. For volume, there are only these three for now. And we go now for the weight. Okay? Sometimes we want to know the water content. Water content is ratio of weight of water on weight of solid. Okay? No, not volume anymore, weight. So if you have the weight of water and you have the weight of the solid, you can do this ratio, and by multiplying this by 100, you can get water content or moisture content. The next relationship for the weight we have is unit weight. So unit weight, that is easy, right? Weight divided by volume, that is unit weight. So it means the total weight we have here divided by total volume. That means the total unit weight of the soil. Okay, so sometimes you can estimate this by doing by using this formula, because the total weight is weight of water plus weight of the solid. Okay, so if you want, you can estimate this by using only weight of solid. How can you do that? Very simple. You come here, in this definition, you have the water content, right? So in this formula, you can get the weight of water here. Weight of water will be the water content multiplied by weight of solid. Okay, so if you do W by WS plus WS, W by WS is the weight of water by using this from this relationship, weight of water. W by WS will be this plus WS, which is weight of solid. In that case, you can easily write this, obtain this. So remember that you can obtain the unit weight even if you don't have the weight of the water, just by using the water content. If you have water content, you can obtain that. Okay. Third relation for the weight, we can estimate also dry unit weight. Dry, it means no water in the soil. It's dry, not partially saturated, not saturated. It's dry. When we say dry, it means there is no water in the soil. So in that case, the only weight we will have is the S, the WS, weight of the solid. Okay? So in that case, you just divide the weight of the solid by the total volume, and you will get the dry unit weight. Because if it is dry, it means in the void in the soil are just filled of air. And as we assumed, the mass, the weight or mass, if you want, the weight of air is very small. We can neglect it. So we ignore that. That's why if the sample is dry, the weight will be only the weight of solid. So dry unit weight, weight of solid, and divide by the total volume. Okay, so we have three relationships for the volume and three relationships for the mass or weight. I'm saying always mass because I know that this formula, you can estimate this also by mass. In that case, it will not be unit weight. It will be density, mass density. And this is what we are going to talk about now. Sometimes, because in international system, density, kilogram per cubic meter, some people find that this is more convenient than using the weight. Please make difference between weight and mass. It's not same. In here, it is not same. Mass in kilogram, weight in kilonewton. Okay. So unit weight means, for example, kilonewton per cubic meter. But here, mass density, kilogram per cubic meter in international system. So these three, the last ones, you can use also the mass density to estimate them. and it will be no problem at all. In that case, instead of W here, W, WS, W, W, you will have M. M standing for mass, mass of water, mass of solid, and total mass. So in that case, we can get the moisture content, water content, by just doing mass of water divided by mass of solid, because it is just a ratio. See, so you can obtain the water content by using the weight or by using the mass. Same for density also. Density, unit weight. Okay, density using weight, density by unit weight by using the weight, and density by using the masses. So the total density will be total mass, which will be M here, divided by total volume. And of course, total mass will be mass of solid plus mass of void. Okay, which is the void here is just mass of water, because we know that mass of air is neglected. Okay, so I will fix it later. So we can obtain the same way we did here. Instead of WS, we can use MS, mass of solid, to obtain this density also. And the last one, dry density. In the same way, we can obtain dry unit weight. We can also establish dry density if you are using masses. So it will be, because when the sample is dry, once again, no water. So the total mass will be represented by the mass of solid only. Okay, so in that case, you take the mass of solid, divide by total volume, and you get the dry density. Yeah. Sometimes you need to go from weight to density, because sometimes you are working on the construction site. For example, you are working with the kilograms, so it will be easy for you to go with this density, mass density. But sometimes you need to calculate, for example, the pressure, the stress in the soil. So in that case, working with the weights are convenient. So sometimes you will need to convert, to go from this, for example, to this, or from here to here. So you can convert, you can obtain the unit weight by using density, by using this formula. Okay, so because normally, if you don't divide by 1000 here, you will be getting your unit weight not in kilonewton, but only in newton. So this is just conversion. The y divided by 1000 is just to convert it from newton to kilonewton. Because if you multiply this density r g is just the due to gravitation, which is 9.81 something. So you can use this formula. If you have kilograms, you were working, for example, suppose you were working with the weight, the densities, and you have mass, working with mass on the construction site, and then you want to go to switch to weights, you can use this formula in that case. Okay, so unit weight of water, just indication here, unit weight of water is 9.81. You need to know this, please. You need to remember this at any time, that unit weight of water is 9 point, some people take it like 10 to make it very simple, but you need to remember this one because no one will give you this. You need to remember it, guys. Okay, so please, we will not be going with both unit weight and densities. You will just be going with one of them. Okay, I will choose to go with this unit weight, but remember, everything you see as formula with the unit weight means this gamma, you can easily replace it with this one, with this rule. Okay, it's same, no problem, because they are just ratios. Remember this, these three as relationship using the volume of the soil, and these three as relationship using the weight of soil. This is all I want for now. Okay, let's continue. The G, just to before continuing, the G here is saying, the G I put here for gravitation. Now let's talk about the relationship among this unit weight, void ratio, monster content, and specific gravity. Please notice that in here, there is no porosity. You remember for porosity, of course, we just talk about this porosity. Here we want to focus on the void ratio. You remember void ratio also, of course. Okay, let me go back. Here, void ratio is this. You need to remember that. Porosity is this. You need to remember that. This degree of saturation, moisture content, unit weight, dry unit weight. But I'm talking about this. The following section is about this one. Mainly, it means if you have unit weight, if you have a void ratio, how you will use it to obtain many other parameters. Okay, I will put this here because this is what we have seen so far. Okay, and we will need it to continue this video. So all of them are here. The void ratio, porosity, degree of saturation. These three are the three relationships for volumes. Water content, unit weight, dry unit weight. These three are for the relationship of masses. And sometimes you will have a saturated unit weight, but saturated unit weight, if you know this total unit weight, it's okay. It's safe. Okay. So if we consider this situation, the three phases are here: air, water, and solid. But in this case, we will take the volume of solid as 1. Please follow this very carefully. If we take 1, it means we will consider that the volume of solid is, for example, 1 cubic meter. Okay, for 1 cubic meter of the volume of solid, what will be the volume of the air? What will be the volume of water? What will be the relationship between mass, weight, and volume? Okay, you will see that all the relationship we will derive from this, all of them are turning around the void ratio, E. I will explain how you can use this advantage of this later in during your exam or in practical situation. Because if we consider this, like Vs is 1, then the volume of void will be exactly equal to E, means the void ratio. Starting from that, because in the definition of the void ratio, it means void ratio is volume of void divided by volume of solid. Okay, the original definition. That's why I told you that you need to remember this original definition. These 6, 1, 2, 3, 4, 5, 6. You need to keep this one, at least this, you should remember them. Then the rest, I will show you how to derive the rest of the formula. And in any situation, it will be easy for you to go through, So, in this definition, V, volume of void, volume of solid. So if we consider that the volume of solid is 1, then it will be V divided by 1, and we will have the void ratio is equal volume of void. That's it. Okay, that's why I say the volume of void is numerically equal to the void ratio E, and that's what we wrote here. Okay, then if we consider this specific gravity, we have talked about this in the previous videos. Specific gravity is the gravity of soil, not the whole soil, gravity of the solid divided by gravity of water. And for this, you can take gravities or weight. You can also say it is weight of the solid divided by the weight of water. Okay, so by using this specific gravity, unit weight of solid divided by unit weight of water, the unit weight of solid is equal to, as this formula shows, unit weight of the solid, not total unit weight. Be careful. Unit weight of solid is the weight of solid divided by the volume of solid. Ws divided by Vs. So it means by replacing this unit weight of solid with its formula, which is unit weight of solid divided by unit weight of divided by volume of solid, we can get this formula. So this density, specific gravity will be equal to Ws unit the weight of solid divided by these two, volume of solid, unit weight of water. In that case, we can consider this. The weight of soil will be specific gravity of the soil multiply the unit weight of water. Okay, that is, you can obtain this from here if you want. Weight of soil is Ws can be obtained from the specific gravity and the unit weight of water very easily. I'm not sure if everyone understands this. You need to understand this formula. Okay. Specific gravity, unit weight of solid divided by unit weight of water. Then the unit weight of solid is weight of solid divided by volume of solid. Ws on Vs. So by replacing it by its formula, you will get this. And then weight of solid will be specific gravity multiplied by this Vs gamma W. But remember that the Vs is equal to 1. In that case, you will obtain that Ws equal specific gravity by gamma W, unit weight of water. Do you understand that? From here, you use this equal this. From that, you can obtain Ws. Ws will be specific gravity multiplied by Vs multiplied by unit weight of water. But since Vs, volume of solid, is 1, then you will end up with Ws is specific gravity by unit weight of water. You multiply these two, and that's all. Okay? From specific gravity. And for the unit weight of water, for the weight of water, for weight of solid, I hope it understood. For weight of water now, you use this relationship. We know that water content is weight of water divided by weight of solid, okay? So from this, we just take the weight of water as product water content multiplied by weight of solid. But you remember that weight of solid, we have already the equation for weight of solid here. So since weight of water is W, water content, multiplied by weight of solid, so we will multiply this weight of solid by W, unit water content, and we get the weight of water like this. Okay, that's why you see the only difference is W, the water content, because weight of water is water content by weight of solid. Okay, so we have weight of solid, we have weight of water. So now let's go to the volumes. Of course, we have the volume of solid is 1, and by using this formula of void ratio, we have established that the volume of the void is equal to E, which is void ratio. Okay, so the total volume will be, of course, volume of solid plus volume of void, which means V, the total volume, is 1 plus E. Okay, how about now volume of water? How do we find that? Okay, we will go exactly here. The weight of water we have established here. Weight of water divided by unit weight of water. You will obtain the volume of water, of course. Okay, weight divided by unit weight, you obtain volume, because the weight will be in kilonewton. Unit weight is kilonewton or cubic meter, for example. So if you divide weight by unit weight, you will get volume. Do you understand that? So by dividing the weight of water, which is here, W, water content, by specific gravity multiplied by unit weight of water. We divide this by unit weight of water, which is gamma W. So it means that this gamma W will be divided by gamma W. And we will end up with W by specific gravity. This is how we obtain the volume of water. Okay, so now we have obtained everything for the three phases. Solid phase, we have its volume and its weight. The liquid phase, which is water here, we have the volume and we have the weight. For the air also, the gas phase, we have its volume, because if you do the volume of void total minus volume of water, you will get it. But the mass, the weight, we don't need, of course. So we will try to establish those 6 formula by using only this new established relation, and you will see what will obtain. Okay, let's go. Of course, you will not need this void ratio. If you do, it will be just E equal E, but we can do if you want. So if you replace volume of void, which is what here, E divided by volume of solid, which is what here, 1. So you will end up with E equal E. There is no meaning. Okay, if you go with N, no need to go with that also, because you will obtain, if you do VV, you will obtain this, exactly this. VV, volume of void, which is E, divided by total volume, which is 1 plus E. So you will end up with this one. You agree? Okay. Now let's go for this one. Degree of saturation. What will you obtain by doing that? Oh, this one we have already estimated. Okay. Weight of soil, we have already estimated. Weight of water, we have already estimated that. Let's go for the degree of saturation. Degree of saturation, the formula is saying volume of water divided by volume of void. Okay. VW divided by VV. Okay, let's come here. What is VW? VW is water content multiplied by specific gravity. This is VW. And what is V of void? Is just E. Okay. We didn't need this actually. Just here directly. This is not necessary. I will correct this later. Just go directly to here. So you will get W means water content multiplied by specific gravity and divided by the E. This is what you will get. Okay. This one is too long, unnecessary thing, because it is just using the volume, obtaining the volume of void by doing mass weight divided by unit weight. So we come directly here. Just take the volume of void, which is here, and you divide it by volume of, the volume of water, which is here, and you divide it by the volume of void. This is what the formula is telling us here. Okay, degree of saturation, just S. SR is mainly in French. People are saying that. VW here divided by VV, volume of void. Okay, so water content by specific gravity, and you divide it by void ratio. You will get your degree of saturation if you have this situation. Okay, and we can go from this formula, we can estimate it, because S, degree of saturation, is equal to WGS divided by E. So from this S equal this, we can obtain this formula. This formula is very famous, actually. People use it a lot in geotechnical engineering. SE equal WGS. Very interesting formula. People use it a lot. So keep it in mind. Okay. Next, we have finished with degree of saturation. Water content. Also, I think we don't need, because it will be almost same. If you want, you can do it. WW on WS. WW will be this one divided by WS. If you divide, you will end up with W equal W. So no meaning. You don't need to go for that. Okay. But if you want, you can go. Okay, let's go for this one. Unit weight. What will it be? The formula of unit weight. This is what we have here already. We have obtained on the very first step, very first relationship we have established. Okay, so unit weight is total weight divided by total volume. That's the total unit weight. Okay, so if we come here, what will be the total weight? It will be WS plus WW. Weight of solid plus weight of water. That is what we did here. Weight of soil, GS gamma W is the weight of soil, weight of solid. S is for solid, sorry, not soil. Plus weight of water, which is here, divided by the total volume. The total volume is V, it's here, 1 plus E. So by simplifying this, you can get easily this formula. So the total unit weight is equal to this one, 1 plus water content, don't forget water content, and multiply by the specific gravity of the soil and unit weight of water. The unit weight of water, you should never forget it. And you divide it by 1 plus E. Okay. Do we really need to do for the dry density? I don't think we need it, because it will be just WS, and you divide it by the total unit weight. Okay, it will be GS gamma W divided by 1 plus E. Very simple. The only problem resides in here, how to establish this. And the key is using specific gravity and using water content. That's all you need. Okay. Okay, let's go for dry unit weight. As I said, it's very simple. GS gamma W on 1 plus E. Okay. Because it will be only, if it is dry, means the water is, the water is gone. No water. It will be only the solid. So the weight of the solid, GS, and you divide it by the total volume, which is 1 plus E. Like this. Okay? Yeah. So you have dry unit weight. Let's continue. Now, we will use this opportunity that we have been given here by the degree of saturation to get even our void ratio by just using the specific gravity, unit weight of the water, and unit weight, the dry unit weight in this one. It's very sad, but some people are confusing the dry unit weight and the unit weight of the solid. It's not same. This dry unit weight and this one, gamma S and gamma D. Please, it's not same. Gamma S is the weight of solid. You divide it by the volume of solid. Everything is for the solid. But gamma D is the weight of solid divided by the total volume. That is the difference, you know? Because gamma dry is like you have a block, a sample of water, of soil, sorry, sample of soil, and that sample of soil has some void inside. When those void are filled of water, the sample is saturated. But when water evaporates, for example, there is no water in the void. You still have the weight of solid, but the volume is larger than if you crush the sample and make it only solid. Can you make a little imagination? Use your imagination. Just try to imagine what I'm saying. If the soil has some void holes in it, then the volume is higher, larger than if you crush the soil and compact it without and try to make less as possible to obtain the less void. I mean, in that case, you will have two volumes. Total volume, which include volume of the soil, the grain of the solid, the soil particle, and the volume of the void inside. But if you make the soil compact without void, then the volume will be smaller, and the volume you will get will be only the volume of the particle, the soil particles. Okay, so don't be confused. Dry unit weight, it's using the total volume. Unit weight of the solid, it's using the volume of solid. So we can use the dry unit weight and unit weight of water and the specific gravity to obtain the void ratio. Okay, so just one thing, very good remark. Please, everything we have established here, as you can see, the green ones are the new relationship we have established. Okay, in all of them, the key we have is this E, the void ratio. You have E here, you have E here, you have E here, and E here. So this means my advice, if you have a problem, exercise or exam or in practice, and the information you are looking for or the information you have is just void ratio. If you are looking for void ratio, if the question is asking you, what is the void ratio? Then first thing you need to do is this. Do this. And remember this form. I'm not asking you to memorize all these formula. It will be difficult. Just try to remember how to establish them by using the specific gravity and the definition of the preliminary definitions. So I'm sorry, but this definition, you have to remember the definition. You have to remember the definition of void ratio, definition of porosity, definition of degree of saturation, water content, and unit weight, dry unit weight. You have to remember that. Not the formula, but the definition. You have to remember that void ratio is volume of void divided by volume of solid. This kind of thing. Okay? So if you have this kind of situation where the key word is void ratio, in the given data, you have void ratio, or the question is asking void ratio, immediately you should think about this method. And the method is easy. Just give 1 to the volume of the solid. And from this, you can establish all the rest. And after establishing this, you can draw this equation, this relationship very easily. That is my advice. Okay, let's continue the next step. We will do same thing, except that in this case, we will consider that there is no void. There is no air. The soil, our soil is saturated. It's full. The water is full. As you see here, we have only 2 phases, the solid phase and the liquid phase. No air, no gas phase. In that case, what will happen? But of course, the volume of solid will still remain 1. Okay, that will not change. And if the volume of the solid is 1, you will automatically have the volume of void is E, as we explained already by using this. Volume of void divided by 1 means E equal to volume of void. So these two will not change. And the total volume also will not change, which is volume of solid plus volume of void. And here, since the void are filled of water, so the volume of void is automatically equal to volume of water. We don't have air. That's why we have here volume of void equal volume of water equal E. Volume of void equal E means the volume of water is equal E also. Now let's go to for the weight. Weight of the solid. By using same situation here, specific gravity, I have explained this already. The specific gravity, Gs multiplied by Ws and divided by the Gs equal gamma S divided by gamma W. And then the gamma S, the formula of gamma S is weight of solid divided by volume of solid. Okay, so by replacing the weight of gamma S by its formula, we obtain this. And you, by using this one and this one, you can say that Ws equal Gs multiplied by Vs multiplied by gamma W. But since Vs is 1, as we say here, so you will get Ws equal gamma W by Gs. You will get here as the weight of soil. Okay, and by using this water content relationship, we have again weight of water equal water content by weight of multiplied by weight of soil. You can use that, but you can also use this very good opportunity, considering that the volume of the volume of water is E. Sorry, volume of water is E. By using this opportunity, you can multiply the volume of water by the unit weight of water to get the weight of water. Because we know that unit weight is weight divided by volume, right? Then you can get the weight by multiplying the unit weight by the volume. Okay. So we multiply the E, the volume of water, multiply by unit weight of water, you can get the weight of water. That is very simple formula, okay? Unit weight equal weight divided by volume. So weight will be equal to unit weight multiplied by volume. So we have volume here. Volume of water is E, and unit weight of water is known. Well known. I told you since the beginning. You should know that. Then we can say that the W, the weight of water, is E gamma W. So we have now this key, I will say key formula or key point. Then we can use this again, and following the definitions we have here, we try to establish this definition by using this. Of course, now we don't have air and everything is saturated. So E, you don't need to do it. It will be same. And also it will be here. Degree of saturation, if you do that, you will end up with 1 because the soil is saturated. But you can do if you want. Let's do, you will see. VW in volume of water divided by volume of void. Volume of water is what? E. Volume of void is what? E. So E divided by E is 1 because it's saturated, 100% saturated. Okay, it's saturated. So okay, you can do also this one. The water content. Water content is also, if you take a W here, W weight of water, you can do, if you want, E gamma W divided by the weight of solid, means GS gamma W. Okay, in that case you will get E divided by GS as water content. You can do. The big difficulty is for you just to establish this. Once you have established this, the rest is very easy. You can derive it by yourself. Saturated unit weight, because in that case, the unit weight, the total unit weight will be just saturated unit weight because the soil is saturated. So it will be weight of what of solid plus weight of water and divided by total weight. So this one, weight of solid plus weight of water is here, and divided by the total volume, 1 plus. So by doing that, you can obtain this formula also. Okay. And dry unit weight, in that case, means when the total water is gone, it will be same as previous, almost as previous formula. Okay, it will not change. The weight of solid divided by the weight of the total volume, which is 1 plus E. Okay, yeah. Next, you remember the formula we established for degree of saturation in the previous slide. We can use that formula, and since S is 1, this formula, this one is not from here, from this slide, from the previous slide. We have established this formula when the soil was not saturated. So if you consider that, and I told you even that this formula is very famous in soil mechanics. Okay, so by using this formula also, you can use the opportunity given to you here, which is the soil, the degree of saturation is 100% or 1. Use it, and you can get this relationship. So if your soil is 100% saturated, you can easily get the E by using this formula. E is W, means water content, multiplied by the specific gravity, like this. Yeah, because S is 1, it's saturated. The soil is saturated 100%. Okay. Okay. Now, as I told you, some people want to work with in international system. Okay, using international system, you can use only the density instead of weight. You use density, and instead of weight, you use mass, and instead of unit weight, you use density. So this is just example. We have done this already. Everything we did before, when the soil was not saturated, just replace, when you see gamma, replace it by rho. See, instead of gamma, we have here rho W. Yeah, and same, the E. So I will not spend time on this, please. Just replace what we have done before with the unit weight. You can do it by using density. Instead of weight, we have here mass of soil, of solid, mass of water, and of course mass of air is neglected. So gravity, specific gravity also say, this is what is interesting for specific gravity. It does the solid divided by water. Unit weight of solid divided by unit weight of water. You get specific density. Weight of solid divided by weight of water. You get specific density. Mass of solid divided by mass of water. You get specific gravity. Something like that. But normally, just use this. Okay. And here, you can use, instead of mass, you can use rho. Rho S divided by rho W means density of solid divided by density of water. You can obtain the specific gravity also. Okay, it's better than using this weight in mass. These are not really actually used, so I don't advise you to use this. Just use unit weight or density. Unit weight or density. Okay, density of rho S divided by rho W. So we established again the weight of, not weight here, mass, sorry. Okay, because I just copy from the previous one and I replace mass of the soil, of solid, not soil, mass of solid. S is not for soil, S is for solid here. Okay, solid phase of the soil. And mass, not weight again, mass of water. Okay, I don't have time to correct this, but I hope you understand. So for the degree of saturation, we obtain the same formula we established before. We can repeat it again, but here you see the only thing will be just here, it's rho, it's density, and the density will go, and you have this. That's all. Water content, in this case you should use the mass, and you can get something like that. Water content is, from the water content you can obtain the mass of water and use something like that. The density also, just replace rho by a unit weight by rho. Unit weight, you replace it by density. The weight, replace it by mass in the previous, and you will get same. Okay, so we will not spend much time on this. Saturated, you can obtain same thing we did with the weight. We can do it with the mass also. I hope it okay. And the density of water is about 1000 kilometer per cubic meter. Unit weight of water is 9.81. I remember at that time when I was bachelor student, our professor, he just gave everything with the masses and density. And in the exam, he just came up with the unit weight. Yeah, it was like some people it was confusing because many people didn't consider that. Okay, let's continue now. We have finished with the void ratio. We will now go with porosity. So the previous section we have explained is when you have void ratio and you need establish relationship with void ratio. Now we will do the same thing, but this time we will be using porosity instead of void ratio. Okay, so I will put again these are like key formulas, so we should keep them in mind. We keep these here because we will need them. These are like definitions. Okay, the whole chapter is around this, so please don't forget. This time we will consider this kind of model, but instead of taking the volume of solid 1, now we take the total volume is 1. So V is 1. So it means we consider a unit volume of 1 cubic meter. And then we try to see what relationship we can draw from here also. It will be same procedure. So I will be going a little bit fast. Okay. But it will be same. There is no big difference. Okay, just remember that the big difficulty is how to establish this. Once you have this, you just follow this definition and you can establish new relationships between weight volume. Okay, so if V is 1, if you come here, you will see the E will be what? VV divided by VS. It will not help you, not much. We need a place where we have total volume. So in that case, if you come here, N porosity is VV divided by V, the total volume. Actually, you don't need T here. T here is standing for total, but you don't need it actually. You can just say V like here. So here, the V is 1. It means N, the porosity will be equal to volume of void. That's what we will have here. And then if porosity, the volume of void, VV is 1, is not 1, is N, means the porosity, you get this, and the total volume is 1. You can get from these two, you can get the volume of solid, because volume of solid will be the total volume minus the volume of void. Okay, so it means 1 minus N. 1 minus N to get the volume of solid. This time it will be like this. So it means we have the 3 volumes we were looking for. This one, this one, this one. Okay, let's go now, move to the masses, the weights. Specific gravity, always we use it. Unit weight of solid divided by unit weight of water. Means weight of the solid divided by volume of solid and divided again by unit weight of water. From this, you can obtain the weight of solid is specific gravity multiplied by Vs multiplied by gamma W. But in our case here, Vs is not 1. Vs this time is 1 minus N. You see? So it means that the weight of solid will be 1 minus N, means Vs, multiplied by gamma W multiplied by Gs. That's what we have here. See? So Gs by gamma W, 1 minus N. We have weight of our soil. Very simple, right? Then what we do next is we try to obtain the weight of our water. We can just come here using this water content, this formula. Weight of water is water content multiplied by weight of solid. Okay, so we have the weight of solid here. We will just take this weight of solid and we will multiply this by water content, and we will be able to obtain our weight of water like this. Can you see the difference is just W? Difference is just this W, water content, between the weight of water and weight of is obtained from this formula. Okay, in that case, I think after obtaining this weight of water, we have everything we needed. All the weights and the volumes of the 3 phases we can obtain this now almost. Okay, so we now try to obtain this formula, these 6, by using this. Okay, first the E, if you want, E is V, volume of the void divided by volume of the solid. If you do that, you will obtain exactly this formula. Exactly. You will see volume of void will be what? N. Volume of S, the solid, will be 1 minus N. 1 minus N. This is how it works. Okay? Yeah. So if you forgot this formula, you can do that also to obtain. Okay, we have the E. The N you don't need. If you do that, you will end up with just this one. Degree of saturation. How will it be? Degree of saturation, as the formula so, it volume of the void divided by volume of water divided by volume of void. Okay, what is the volume of water here? What is volume of water? Very simple. Volume of water, we have the weight of water. Just take weight of water and you divide by the unit weight of water and you will get the volume of water. Of course, you can add this here also, no problem, but it will be very, like, how to say, very crowded. If you add it here, it will be too much. That's why we didn't add it here. But it's safe, okay? Just divide the weight by the unit weight and you will get volume. That's why this is the weight of water. This is the weight. And you divide it by the unit weight of water. That will give you the volume of water. Now the volume of void, because we need the volume of void. Volume of void is just N. That's why we have here N. So you will end up with degree of saturation using this. So this relationship is giving you the degree of saturation by using porosity and this specific gravity and water. Okay. Next, the unit weight. Unit weight, which is the weight, total weight, divided by total volume. Total weight will be, wow, it will be too much. This weight of solid, I'm always mistaken saying solid. It's solid, okay? Weight of solid plus weight of water. So if you do that, you will get the total weight and you divide it by total volume, which is 1 here. Very lucky situation. So in that case, you will have this weight of solid, which is here. Sorry, the parentheses here are not well written. Weight of water, it's here. So by simplifying, you can obtain this formula. I think there is a mistake here. Let me correct it. Yeah, I think it should be plus here. Here. Here should be plus. Let me correct this. And we continue, okay? Okay, I have corrected this. So it should be plus here, okay? So hopefully when I see a mistake, I can detect it easily. Means I'm just not copying and pasting. But it means also you have to be careful. Sometimes I can make mistake, okay? But I'm very careful. I don't make mistake very easily. Let's continue. The unit weight can be given by this formula, okay? And next one, last one, is dry unit weight. The dry unit weight means there is no water, so the only weight we will have is the weight of the solid divided by the total volume. So it means only this one, okay? the total volume is 1. So we will just getting this as total as dry unit weight. Okay. Yeah. So in this case also, as you can see, the green ones, the new formulas we have established. Everywhere you see it is N, porosity, N, N, N. Everywhere, N, N. Sorry, here, this N and this one, same. Okay. It just the font, maybe. It's same. It porosity, N, N. Okay. Some people are easy to get confused. So the N here is same. Don't worry. So it means that if you have exam or exercise or a practical problem and you have information, the information you have or you have, it is what you are looking for is the porosity. Maybe you might be interested in like in establishing this formula. Okay, don't memorize them. Trying to memorize this is a mistake. Just try to know how to establish this. If you know, then it will be easy to get this formula by yourself. Okay, now let's go in the same way, same situation, means the total volume is 1, but in that case, with different saturation. This time we will consider that there is no void, there is no air. The void are filled of water, means the soil is saturated. Okay, soil is saturated. In that case, what will happen to the volume of the water and volume of void and volume of water? We will have this volume of water will be same as volume of void, which will be N. Okay, same as previous one, but this time the volume of water is N also. The volume of solid 1 minus N, something like this. Okay, so for the weight, by using still the specific unit weight, this is not different with the previous one. Okay, so don't need to explain this again. Same as the previous slide. And volume of water, the weight of water is easy. Just multiply the volume of water multiplied by the unit weight of water. So gamma W multiplied by, we can use gamma W easily because it's not really something difficult. It's like something that doesn't change. Gamma W, the unit weight of water is unit weight of water. It doesn't matter where you go, it's same. In any situation, it's same. It doesn't change at all. So by multiplying the volume of water, which is here in this situation, N, multiplied by the unit weight of water, you will get the volume of water. Hey, what I'm saying. You will get the weight of water. Volume of water multiplied by unit weight of water, you get the weight of water. Yeah, something like that. So after getting all this, we go now for establishing our formula. So as I told you, the E, if you try, it will be exactly this. And saturated unit weight. If you try, it will be 1, because in this case, it is the water is full. The void are filled full of water. So let's go directly to this one, unit weight. This unit weight means saturated unit weight. The weight of soil, the weight of solid plus weight of water divided by the total volume. Total volume, which is 1 here. So you can get this formula. And dry unit weight means only the solid phase we have. So solid phase, the weight of solid phase, because the weight of air is not included, is we can neglect that. So by neglecting that, we can consider only the weight of solid divided by 1. That will be our dry unit weight. Okay, this one, water content, the weight of water divided by weight of solid. So weight of water, which is NW gamma W, sorry, divided by this weight of solid, and you will get this something like this. Yeah. So I think it's not difficult. Try to establish the formula by yourself. Don't memorize them. Memorizing is not good. We are saying that a good engineer is not the one that can memorize everything. The good one is the one that knows, information he needs to get the work done. And most importantly, he knows where to find and how to get that information. Okay? If you are engineer and you are memorizing everything, you are not good engineer. Okay, saturation. Since here the saturation is 1, we can establish this. We can establish this formula by saying S is 1. So maybe it can help. So if you are able to do this, establish this figure, it will become just like game for you. Just do it, and you will go through any difficult situation, any difficult exercise. It doesn't matter how difficult the exercise is, you go through. Okay. Okay. I hope it's okay. You understand everything. Now I will just show you this part, the fifth part, some various relationship. Please, I will not explain this. If you are watching the video, just make pause and try to see this relationship if you want. So you have given data here. For example, if you have water content, specific gravity, and void ratio, you can use them to obtain this, to build this relationship. Okay. Yeah. This is like, how can I say, summary of what we have done. Everything we did is included here. Just check. Okay. And also, we have this table that's showing us some soils in the natural state with typical value of void ratio, moisture content, dry unit weight. Okay. If you have loose uniform sand, the void ratio is likely to be 0.8. And the water content is likely to be 30%. In natural state, the dry unit weight is like 14.5, about that. Okay, it's not always that, and so on. Dense and this value, you can see there are a lot of type of soils here. Just check by yourself. Okay, I think I don't need, there is nothing to explain here. Just information. So these value are sometimes you can use them to judge if your result is good or not good. For example, if you find this loose sand and you find that the void ratio is about 0.3, maybe you might be wondering, is this my result good? And maybe you will go and double check your your calculation, the procedure you did to obtain the result. Okay, something like that. So please, I will end this now because maybe the video is too long. And I hope you have learned something. Please just share with your friend. Okay, and if you have any question, don't hesitate to just contact me. All right, so we'll see you in the next video. Thank you.